let's graph a piecewise function. So this piecewise function is going to have two pieces. I'll use the green one for the left function and the black one for the right function, if I remember. And piecewise functions are written so that the one on the top is starting furthest to the left on the graph, and the one on the bottom is starting more to the right. So as you go from top to bottom, you're moving from left to right on the graph. So let's start with the graph of x plus 2. And since that's going to be my only thing that I'm going to start with, I'm just going to kind of make the full graph. So x plus 2 is a linear function. You can always tell a linear function because the highest power of x is 1. You know that if a power of x is 2, it's going to be a parabola. You know if the power of x is 3, it's going to be kind of a squiggly thing. And those are the main family of function ones that you need to know in terms of power functions. So I know it's going to be linear, and it's going to take the form of y equals mx plus b, where m, you'll recall, is the slope, and b, you'll recall, is the y-intercept. It's the y-intercept because anything on the y-axis here, as you can see, they all have a value of 0 for x. So if I put 0 in for x, then this whole term right here would also be 0, and all I'd be left with is b. So my y-intercept is always going to be b. So my y-intercept in this particular case is 2, so I know I'm going to have the point 0, 2. My slope is 1, because that's my slope right here. We don't have to write 1. So I'm going to have a line with the slope of 1, so I'll go 1, 1, 1, 1, negative 1, negative 1. And I can see that I would have a nice line kind of looking like that, going in both directions. Okay? But it's telling me we only want this function here where x is less than or equal to 1. So where x is 2, I don't want that. Where x is 5, I don't want that. I want to erase all of this here except up to where x is equal to 1. And it says I want this line for x less than or equal to 1. So that means since it's equal to, that is going to be a closed dot right there. So that is the way the first piece of my function looks, just using the slope-intercept form of a line. Now, as far as the second part goes, if you know transformations, this is pretty easy to do. It means I have the parent function here is the function x squared, and we know that's a parabola. And if I remember how to do transformations, this is saying it is the parabola of x squared shifted to the right one spot. Now, if you don't recall that from Algebra 2, that's fine. We can still graph the piecewise function just using a very simple t, as long as we remember that the graph of x squared, the parent function, is going to be a parabola. So let's make a little t right here. And I have my x, and then my y is x minus 1 squared. Now, I want those for where x is greater than 1. Well, I know it doesn't say greater than or equal to, but greater than 1 includes the point 1.000000001. It's just a tiniest bit to this side of 1. And the way I'm going to indicate that is when I figure out what the y value is, I'm going to indicate that with an open circle. So let's use 1 in our little t here. And I say when x equals 1, well, that would be 1 minus 1, which is 0. And I square 0, I get 0. Let's use a number a little bit higher. Let's use the number 2. Well, 2 minus 1 is 1. I square that, I get 1. Let's use the number 3. 3 minus 1 is 2. 2 squared is 4. I get the point 3, 4. If I go even one more, 4, I would have 4 minus 1 is 3. 3 squared is 9. So I can kind of begin to see what this is going to look like. At the point 1, 0, I have an open circle. But at the point 2, 1, I have a closed circle. The point 3, 4, that is also part of the graph. The point 4, 9, that is also part of the graph. And I can begin to see my parabola has taken shape right here. And that's what it looks like. And it keeps on going because I want all x's greater than 1. So that is a pretty nice picture of what the graph looks like. Let's see if we can figure out the domain and range. So I can see from my green function that that is going to go all the x's forever to the left. So I'm going to start my green function. I'm going to start at negative infinity. And it looks like I would stop right here at x equals 1. So, but then the other graph, the black graph, picks it up right at x equals 1. And now that continues off into infinity. So my domain is negative infinity to infinity. I do not have any gaps in my x values. All of my x values on this piecewise function here are taken care of. And you can also see that by just looking at my conditions right here. Think about it as if it was a number line. Here's 0, 1, 2, 3, 4, 1, 2, 3, 4. My top part says x less than or equal to 1. So that would include that point right there and everything less. And the second part says x greater than 1. Well, I already included 1, so it doesn't matter that it would be an open circle there because it's already included. And it goes like that. So you can see that my domain is all real numbers. All x's are fine in this graph. Range is a little bit trickier, but I can determine it by looking at the graph. So let's erase this red thing. Well, let's leave this red thing right here, and I can see that on my green function, I am going all the way, well, I start down here at negative infinity, and I'm going all the way up to 3. So I know I'm going to start at negative infinity, and I go all the way up to 3, and it looks like it stops. So then the other graph right here takes over right there, and that is going up to positive infinity. And I know there's a little, I'll use blue in this, I know there's a little gap right here, but I still have all these y values that are covering that gap. So there is really no gap in the range. All the y values are covered from negative infinity all the way to positive infinity. So let's make a comma there. So that is my domain and range of this piecewise function.